Hi everyone, this is Plasma Call number 12. Looks like we have a lot of people and a lot of stuff to talk about. So why don't we jump in on updates from everyone, just randomly chime in, and then we can just jump into it. And if there's nothing, we'll just jump into it.
Well, I mean, okay, I can give a quick little thing. I have been working with Jing on a crypto economics study / Jing blog post about Plasma, kind of doing an overview of the different research topics and just all the different concepts. But I'll let Jing continue a little bit. Assuming. Don't hear you in case you're speaking.
Oh, what? Sorry.
Talk about the blog post.
Oh, I mean, it's being worked on. I'm on this call to just listen to people talk about what they're working on. A lot of people I asked if they know what Plasma is. They said, oh yeah, it's side chains. So I figured maybe there should be some kind of level overview or explainer out there.
So quickly on that subject, at the IC3 bootcamp, we're currently putting together like an entire separate Plasma website.
Awesome.
We're calling it Learn Plasma, but it's basically just going to be like full-blown overview and then in-depth on each of the individual current designs, and then a bunch of other stuff like where you can contribute, what the current open research topics are, what the current implementations that are being actively maintained are, and stuff like that.
Sounds
cool.
Perfect.
So if you want to contribute to that, we need people to contribute to that, and there's not enough content yet. So,
is it live? Where can I find the website?
I can put a link to it, but we are trying to add content today because we're supposed to be presenting stuff in like 3 hours. So,
oh, are you guys at IC3 right now?
Yeah.
Oh, cool. What's going on there? I mean, not necessarily Plasma related, but
a lot of different things. We are doing some Plasma related stuff. We sort of are revamping Plasma MVP again. And trying to build it into an actual, we're taking PyEVM code and just modifying it to work for a Plasma node. And then we sort of started thinking about how to think about Plasma designs in a more generalized way. So sort of fleshing out the idea of Plasma as a framework in some sort of more detail. And then, well, I'll talk about that later when we get to, how do you design smart contracts with Plasma.
I saw that you wrote that you're pushing to a repo with some more simplified, more viable Plasma. Is it a different design from the one you have posted in the past?
Not really. It just simplifies the contracts into basically literally the most simplified thing that I can possibly make. I want to make it readable, and that's what we're going to, on the Plasma website, we're going to describe that in detail. And I just want to avoid any sort of confusing security feature that's only necessary in this one edge case. And we can sort of talk about that later. But
I tweeted about this earlier. I will be doing Plasma XT like over the next few weeks, perhaps. I will be trying to implement it. Do you or anyone else have any good reference from cryptoeconomic aggregate signatures on an implementation with verification and everything?
I have a small implementation in the Parsec Labs repo.
Oh, like a proof of concept or anything?
Yeah, I haven't flashed out all the edge cases. I think there's some grieving attacks where, you post a lot of ones where there should be zeros, and then it...
Okay, which file is it? Parsec contracts.
Yeah, exactly. Parsec contract.
Parsec bridge, TXT.
Yeah, it's in the bridge. It might be on a branch though. Let me check.
Okay, and one more thing. I was thinking that is it possible to do BLS on Ethereum with the new opcodes, BLS signatures with the Byzantium opcodes, because I found what is it? A post from Crypto Stack Exchange that asks that. He has some answer, but I couldn't like verify it really. So
You mean the on-chain data?
Yeah. So like to submit a BLS signature and verify it on chain.
Oh,
I've never seen code for that. I would love to see that.
Yeah, I'm thinking that is it even possible at the current state? That's what I'm asking.
Somehow I believe maybe, although I'm not 100% sure. It will definitely be possible very soon, if not right now. That is like on the, it's necessary for.
Okay.
Yeah, I think we can do multiplications, but with the wrong curve or something like that.
Mm-hmm.
I'm not entirely sure.
is sharding thinking about doing BLS and having it as a native like?
Absolutely.
So you think about adding it natively, so it'd be like as fast as BLS can get?
Yes, basically. But that's going to be on the Beacon chain, which is a little bit different. But yes, by the way, I just confirmed you can do BLS. You just have to implement it. I think there's an implementation out there.
There's an implementation.
Yeah, I think so. But it's just like there's a guy named Carl. Not me. I don't do that.
That's a guy named.
It's with a C, so he's less good.
Right.
Sorry.
Okay. So anyone else?
Yeah, I see many people just did a more viable Plasma implementation. Definitely mine is not the most readable. Also, I try to, maybe it's over optimization. Also, I try to make the so every time you pause a transaction, if there were any outputs, for example, pending for exit, which were input to this transaction and it's included in block, you challenge them automatically. So it may be an over optimization. I will check what Calvin has and another implementation which was also posted today in the notes, and I will see, maybe I will just remove it. Otherwise, yeah, I just continue to work in the code.
Cool.
Yeah, and I see the Calvin uses, he specifies the transaction number explicitly, while I take it from a Merkle proof, which is the same equivalently, but yeah, we just have a different way of implementing things.
So you just do a pair of the height and the position?
Yeah, but well, basically with the proof, you supply extra bits with telling left or right element you supply, so you can just calculate it when you check the proof. Just different approach, not too
with
much.
The block height too, right?
Yeah.
Cool. Sounds good.
Yeah, guys, maybe I can say hi. I've never been on the call. Is that a good time?
Oh, yeah.
Cool. Hi,
Give
everyone.
an introduction.
Yeah. I'm Johan. I'm from Berlin. I'm working on this Parsec stuff, and we have an implementation of minimal viable Plasma 2, which is, I think the two key differences are we're not using how is it called, RLP encoding for transactions. We have our own kind of static size UTXO implementation that we think is parsed faster. So maybe that's a difference. And then we're also not using the thing that we just talked about. So we don't take we don't address previous inputs by block height and position, but we just use the hash of the transaction. But then when it comes to exit priority, we can still use the block height and the position in the block. So that's all the same. And then I've posted a link to our more viable Plasma implementation, but that's still ongoing. So it's very experimental. And I published a small thing on F Research that I call why smart contracts are not feasible on Plasma. So I would definitely like to get some feedback on that.
Can you post a link?
It's in the notes, but I'll post it here as well.
Why smart you just posted it. Okay.
Cool. On the topic of smart contracts, So I wanted to do sort of a brief, and I put this in the ETH research post, but a brief like intuition of why smart contracts are weird in Plasma. The way that I see Plasma right now is that you have these individual state objects, and these state objects live on the Plasma chain, and then they get to move back onto the root chain, right? And so when we're talking about something simple like a UTXO model, the state object is a UTXO, right? And the state object could be converted from unspent to spent under certain conditions, right? So the condition in the UTXO model is, we have a valid signature that from the owner of this UTXO that converts it from unspent to spent. It's also really easy to assign ownership when we're talking about something like a UTXO, right? I can clearly say this person owns the UTXO. And so every single state object needs to be able to move from the smart contract to the from the Plasma contract or Plasma chain to the root chain. And so we need to determine who's allowed to do that, right? Who gets to move this state object? Again, with the UTXO, we can say, well, it makes sense for the owner of the UTXO to be able to withdraw this object, this state object. Things get more complicated when we talk about stuff like smart contracts, right? Smart contracts, we think about not, or at least Ethereum smart contracts, we think about them not really being owned by any individual person. And so it's weird to assign somebody who is allowed to, withdraw that state object from the Plasma chain to the root chain. Right? And you can sort of consider it a state object because it has balance, it has code, and it has state. And so it doesn't really match. And then the other problem is that when you have this sort of public smart contract that anyone can modify, then anyone can execute valid state transitions against that object. And so exits in Plasma can be blocked if you attempt to withdraw the state and then somebody proves that that is not the latest state, right? That somebody proves that there's been a valid state transition. When it's a UTXO, the only valid state transition is a valid spend by the owner of the UTXO. And so it's kind of your fault if you spent your UTXO and blocked your own exit. But if somebody's trying to, if we can somehow figure out who is allowed to call the exit, maybe we just define an owner, then the person can try to exit, but anybody can still execute valid state transitions against that contract. And so that would invalidate the state, right? That's not the latest state. And so I don't think it's correct to think about let's put EVM smart contracts on Plasma. And instead, I think we should break things down into sort of contracts that can have, or that can be broken down into state objects that have clear owners. So like ERC20s, we basically convert the ERC20 into its own Plasma chain. And then, so now you get closer and closer to this nested Plasma thing that got described in the original paper. But we have to define who is allowed to cause state transitions against an object and who is allowed to withdraw that object. And if we can't do that, right, we can't just have general smart contracts because anyone is allowed to change the state.
Can we limit it to some kind of state channel? Wider set of states, not just withdraw, transfer, but just still very limited, not a smart contract level, but
yes,
up to some point. So yeah, okay.
I think what Kelvin is saying is that essentially at every step, if you have an owner, then it's resolvable. If you don't necessarily have an owner, it's difficult to do, for example, DAO-like constructions. You may be able to, but the complexity goes up essentially with those problem sets.
One note on this. So I'm not sure the owner is actually the biggest problem that we have. So imagine that every contract that you can use on the Plasma chain, you first have to deploy on the main network. And then you can kind of...
That may not necessarily be true though.
Yeah, but then that is not necessarily be true, but that simplifies the problem. Then, that you could build a proxy into that smart contract on the main network to request the withdrawal, and you could eventually make sure that it's kind of the same state like on the Plasma chain. But I think the problem is a much bigger one. It's where state transition happens and there is data withholding, right? So subjective data withholding. And then after any data withholding happened to any party, you have to claim all the state in the smart contract invalid because you cannot verify that the transition was correct.
So you can resolve this in some situations. I would argue a lot of the examples that we're talking about by essentially by committing to the more accurate state on chain. And obviously this is very expensive if you're dealing with a very large data set, but there's various strategies to resolve this. Like if you want specific examples, essentially, let's presume that, you know, Alice and Bob agree to enter into some contract, and then the state is determined on some future release data state. Alice submits a withdrawal on the main chain on the data she has available, and it's up to Bob or other participants to update the state. Now, obviously, you cannot have arbitrary unverified state updates, but effectively at that point, if the chain has halted or if there's data withholding that is basically not dealing with that contract directly, then at that point, the most current state gets played out on chain or gets net settled on chain if the given participants agree. If there is additional submitted data, of course, that data would have to be verified in some way. That's the constraint.
And how do you deal with what Kelvin just said, where if these data objects don't have a clear owner, they can be, you know, valid state transitions can be made as kind of a DDoS thing.
So DAO-like constructions are a lot harder. It may be essentially DAO-like constructions may require presumptions on availability as a presupposition of the security model.
And can you imagine a chain that kind of runs a hybrid mode, like Plasma UTXOs, but kind of available, like, I don't know, something with a set of notaries for a smart contract?
Yes, but at that point, that becomes a sidechain-like construction. Yeah, whereby, you know, if the chain halts, the funds may become either permanently unavailable or, you know, adversarially can be taken advantage of.
Well, at that point, you trust the notaries as
which is how federated takes
your as secure as validated.
Awesome.
On the owner thing, actually, could you maybe think of the owner just like as a set, and if you have a large set of owners, right, like even all Ethereum holders, like if you have a smart contract that can be accessed by anyone, and just like the owner set is just every single Ethereum account.
Yeah,
so
you can.
Goes up as you have a larger set of owners.
So you can do that, and the presumption would be that set would be the plasma chain itself, and if you eventually do it as some multi-sig construction of validator sets, then that would be the security presumption. But that's principally with designs that don't have clear defined owners.
Yeah, really briefly on the hybrid model. So this is what we're sort of building here this week, and it's not going to be done by the end of the week, but that's fine. But the idea is that we basically have a Plasma posting board almost. So money is still handled in the Plasma MVP way, and then certain transactions can have extra data attached to them. And logic doesn't get executed on that data inside of the Plasma chain. It sort of gets handled off the chain, which means you can do things like send a transaction that modifies some game state, right? Where everyone knows what the original state was. But that state isn't stored on chain, and it's not possible to withdraw that state back onto the root chain. So in that sense, if something bad happens, you kind of lose all of this state. But for now, it's sort of meant to be for things like games. So if we want to do a Satoshi's Place kind of thing, you can make a transaction that modifies the state of the board, and everyone can sort of execute the state transitions themselves and see what the current state of the board should have been. But that's not stored on chain anywhere. There's no way to withdraw the board back to the main chain. If it breaks, and you're kind of just done with it.
So essentially you're talking about localized data specific to the plasma chain that gets committed to the plasma chain only and isn't verified by the root chain contract. Is that the presumption?
Yeah.
Okay. There are a lot of similarities to certain design patterns in Cosmos, so it could be interesting to, see whether, because I know Cosmos is doing a lot of interesting things along these lines as well.
I'm also curious, like the definition. Oh, sorry. I was just going to say definition of plasma without an exit, and like what is that? What are we actually doing there? We're definitely committing to ordering of transactions, but then, like, what makes plasma?
Yeah, it's basically like it sounds like. Correct me if I'm wrong, Kelvin. I don't want to like speak for your efforts, but it sounds like if you guys remember counterparty, it's sort of like counterparty with deposits and withdrawals is the difference. Like committed deposits and withdrawals. So you can be committing periodically to the chain a hash commitment of state transitions, and it's client-side verified, but the data, the state transitions itself is not verified by the chain, the root chain itself, I presume is the design construction.
Correct. And it's not, nothing is even verified on, it's sort of meant for simple state transitions where you calculate it yourself and you know what state you would have ended up with, and you can sort of present it client side, but that state isn't, the initial state isn't stored anywhere. The final state isn't really stored anywhere. It's all sort of calculated client side.
But deposits and withdrawals are still enforced, kind of thing.
Wait, so
Correct.
how do you then arrive at a state from which you can withdraw?
So it's not, imagine it more like a posting board where you pay, when you make a transaction, you can include some arbitrary data along with the transaction. Right? So you pay some fee to post some data to the board. And then all of the execution on that data is done entirely off the blockchain. There's no logic on that data. It's sort of meant to be, a for fun. Initially it's meant to be a for
right.
fun.
So this like doesn't
just
involve,
like a Twitter.
Like,
yeah.
Right.
It's like no monetary value essentially.
Yeah, it's very in the middle of like Plasma and Loom, where you're paying for stuff with funds that are, that can always be withdrawn back to the root chain, but everything is sort of, all of the information could be lost one day, right?
I bet if you had like very clearly defined end states, then you could play like full games if they're like low enough value and just hope that it doesn't break in the time period that you're playing the game.
Exactly.
And then have some winning assets, but that's of course low stakes.
You can also constrain it, and this requires some type of conversion rate pricing, which requires a DEX or some pricing mechanism. Even Bancor would work for this actually, whereby the total value of the state transitions within the time period is guaranteed to be less than the value of the coins locked up for the validator nodes. Some multiple lower at that point. There's a economic incentive not to break the system because they'll end up losing more. Is an example construction of that.
Yeah.
Elvin, does your design use validator nodes?
No, but it could in theory. Just for simplicity, we wanted something that people can spin up with a single operator node.
Yeah.
So in this context, I don't know if it's super relevant, but I'll bring it up anyway. Together with Chanti, we are working on a thing that we call Sol EVM. We've actually forked off an existing project, and that's a Solidity EVM implementation in Solidity. And the point that we want to get this to is a TrueBit verification game, but for EVM code. So where you can run the very last step of any disputed computation on chain. And I wonder if there's a way to combine these two things, where you post computation requests and then you can challenge someone on chain if his computation response wasn't valid. Or
Wait, so you wrote an EVM interpreter in the in EVM? That's really
That's not yeah. I mean, there existed one. We forked it off from Andreas Olofsson, and I just converted the tests to truffle. I can't claim that I wrote any of that.
I did not know this existed. That's really cool.
Yeah, I think
so we can run an EVM within the EVM within an EVM within an EVM.
Yeah.
Yeah.
EVM's all the way down.
Well, now you need to write an Ethereum implementation in the EVM.
Why don't we start with the Solidity compiler in the EVM?
As far as I know, some time ago, there was something like say Ethereum improvement proposal, I think from Vitalik, for checking the state transition or something like this, like a precompile, so you can just provide some part of state as a smart contract and everything, as a part of transaction, you just check the state transition validity. Maybe we should also do this in parallel. Maybe it should be a core feature of the EVM itself.
That would be cool. Let's find out why this EIP wasn't pushed further.
Yeah, it was posted since like at least half a year ago, and like no one taking it.
Okay, let's check it out.
Very cool.
I don't know if my idea is a little bit too far and preliminary. Do you think if it's worth even making the, I checked the Mimblewimble once again, and they kind of, I think, allow to spend you the output you produce in one block to spend it again. Maybe I'm a little bit wrong. So do you think it's worth even just thinking about the idea, or just forget it and make blocks quite frequently so user doesn't suffer from, like, if he has mainly one output to spend, he just spends it and has to wait at least for a few minutes to spend it again, or just forget about it?
Can you explain? So the limitation in Mimblewimble is that you can only spend once a block, right?
No, in Mimblewimble you can spend many times in the block. And in a minimal viable plasma, in a minimal viable plasma, if you have one UTXO and you spend it in this block, you have to wait until the next block arrives and you just recompute the UTXO set and you spend again.
This happens with every blockchain, I believe.
No, that's not.
No, that's. I could include thousands of transactions in a single Ethereum block from the same account.
Yes,
I just have to,
but not for the same, not for the same value. So the same value for different. Yeah. Okay. Sure. Yeah. But what's the advantage of what Alex proposed?
No. De facto, I think the way it handles the mempool is a little bit different, but theoretically, I think you could do it.
I think it'd be pretty cool because dexes need this. Like if I'm transacting, if I want to have a high throughput, high frequency dex, there might be a point that I want to send more than one transaction per block.
I think they just use what's called, well, they use the confidential transactions protocol. But in a sense, if they sum up all the confidential transactions and they're all valid, you can just make an output. And since you know it, you just set it as an input and they just cancel each other.
Yeah, but with this construction, there's stronger data availability requirements as a consequence.
Yeah, that's why I ask if it's just if we even should consider just trying it now, or just, well, forget about it, maybe do it later.
Well, I mean, you could probably do it later, but right now, like, it would probably expand the contract code pretty significantly. I mean, if you want to do explorations on that, I think that could be worth it. But right now, I think it just could increase complexity is my intuition, but I don't know how everyone else feels.
I wouldn't, but I think it's useful for like potential plasma dexes.
Let me just say one thing on generally, like when we're thinking of doing fancier stuff on Plasma, we really should focus on getting an actual like thing that can be used by the users, because right now it is way too complex to operate. And we've discussed this a lot. So like I've been like holding back, like adding new features, because right now you cannot like actually expect for a user to monitor everything And like even if you code it on the client, this, I believe that even the liveness requirement is it can be managed, but even that is a problem potentially. And requiring exit challenges, all that, before going for further fancy features, I believe that we should like focus on getting this, like the minimal information needed from a user.
Yeah,
Because I don't believe that we talk about this enough, because like we get our contracts, we show our Solidity prowess, but
Yeah, I definitely agree with that.
Devil's advocate. My contract also sucks, but yeah.
No, I think yeah, definitely. That's why I think doing straight payments and stuff like that,
and or some kind of like more standard, not standardized. I said that also the last time, but like libraries that interact with Plasma, for example, or some more design rationale for designing a Plasma chain.
Yeah, in that sense, I spent some time writing the client, so it's just one-click handle also verification, and even the trivial resolution of the like double spans with exit and spending, at least is most trivial part. I don't want to release the Plasma even while I can more or less like quickly finish the contract and the server side is ready. I don't want to even try to release it before I have the client, because the client is like huge amount of work.
Yeah, because I think that users have, like first-time users have even a hard time with MetaMask, which like maybe we can find probably intuitive, but it actually is not, like for somebody who is like new, if you will. And the user shouldn't even, in the ideal case, the user should not even need to care about Ethereum itself.
Yeah, I would agree. And those of you watching the video, I think definitely usability research is always sorely needed in the cryptocurrency space and this areas like.
I'm curious if there was anyone doing Plasma at the UX meetup at, where was it? I don't know.
In Toronto, or?
I think in Toronto, yeah.
The wallets unconference or something? I haven't been there.
It was about the wallets. Yeah, it was about the wallets. But yeah.
The Ethereum magicians, they're starting these rings, which are basically working groups to bind them all. And there is a wallets and UX ring as well. So maybe we should, I don't know, I could jump in and say, hey, we need wallets that work with Plasma as well.
Yeah, exactly. Like I think that like eventually a wallet should be like Plasma enabled.
Yeah,
well, I can make you a wallet for mobile devices maybe during the week or two, but the problem is you don't want to download every block on this kind of client. So it's the point, unless we have some nodes which run the indexes,
I think it's like SPV nodes, like so like
this is the additional level of complexity we talk about.
Yeah, I find that Plasma
SPV is good. Yeah, the SPV on a Plasma is going to be much simpler than the Ethereum Lite client. Yeah, since a Bitcoin like, but yeah, maybe I should just stop working on a client and just put and make an SPV node. Yeah.
I'm just thinking out loud, but it could be possible. Like we could just have some kind of nodes that are the full nodes, like we have in. Let's say that we have Bitcoin Plasma. Okay, please, if anyone is.
It's what we have.
Yeah, but like if you did like a Bitcoin on Plasma, like it could be like that you have the light nodes like polling the full nodes and getting all the necessary data. And eventually, like perhaps you could have like you could even pay some nodes. I imagine that there would be some kind of service provider that would do this. That would act as a secondary operator, if you will. So you have the Plasma operator, and you have clients who act as proxies, intermediaries that guarantee data availability and all that.
Yeah, we should also definitely use like crypto economic like client. So, you have a client that's just, sending you the messages and say, either this is the state of affairs or I will lose a bunch of money. And the central operator is a great person to provide that service.
I'd be curious.
At least for a start, if someone wants to just work in a SPV node, We can quickly arrange it, I think. It's the most difficult part is P2P. Other things I can more or less do in a day.
Yeah, which is why the central operator is like a godsend, because the P2P networks are just awful right now, and so we need these traditional REST APIs and simple database, centralized database scalability stuff.
Yeah, in the short term, you could do something silly like merge in the 0x Bitcoin contract into this and jam it together or something to do validator selection.
We need better developer UX too, because we can't expect that everyone who wants to build a Plasma app becomes a client developer. If you want to build a Plasma app right now, you have to literally build a blockchain client with networking from scratch, and it's entirely unreasonable. Right? We're trying to do it right now, and I basically have to copy PyEVM to have a chance to do this, and it's a nightmare. And so what we want is that people can somehow build Plasma apps in a way that actually makes sense to them. And we're not going to do that if people have to write clients.
And you're working on that. Right?
It could end up being that in the short to medium term, you have to modify the client code. But yeah, P2P is always that's always the hardest part of, writing blockchain code. And it's always like, definitely not enough credit is given for the people doing that awesome work.
Hey, quick shout out to Adrian. So we're using Tendermint to kind of build the Plasma chain, right? And there is SPV syncing built in already. Have you guys kind of, can that be used, or would that be, is that in the same context?
Yes, if you're using Tendermint, you can get extremely short and infrequent light client proofs, right? Because in Tendermint, as long as you have a known validator set, you can, so I only very much understand in the context of proof of stake, so you have bonding periods and stuff at stake. And it's if you have a given bonding period, as long you only have to sync headers once you only have to synchronize with the chain once during the unbonding period. And realistically it works out, you have to download 1 or 2 headers depending on the frequency of the validator changes.
But then the Tendermint code base right now uses a totally different signing scheme, which we can't verify on Ethereum. And
it's RPMD, if I'm not mistaken.
But that is actually, so at 25519, either we get pre-compiled, but it should be possible to, it's pretty straightforward to switch it to SECP. But you have to fork it. It's not configurable right now.
Yeah, +1 on making it configurable.
What is the security, hello?
Yeah.
Hi, what's the security model of SPV in the context of single authority Plasma without operator bonds? Is it how does it actually work?
You have to check every proof by taking the Merkle root from the smart contract.
And what are the proofs about?
You ask another node about, well, whether is in this block there is an output I can spend, and the other node, if there is one, other node can send you a transaction along with the proof that the transaction is in block, and then you can check it on the Merkle root from the smart contract for this block, and then you can more or less be sure.
If you're assuming the operator is honest for this, which I think you have to if you're going to use an SPV proof on a single operator blockchain, then why don't you just ask the operator, and the operator will tell you whether you're whether you have this coin at this time, and you're going to trust the operator as to the validity of the chain anyway, right?
Yeah, of course. As an operator, you can just provide you with a REST API, but we just thought maybe there would be some light nodes with incentives, so they can also monitor it. Maybe operator doesn't want to tell you that there is some output you can spend on this block, and you cannot do otherwise unless you run the full node.
You could actually build a bunch of bonded light nodes.
Read-only clients.
No,
They
but
don't
like
modify the state. They can just host the data. That's all you need, and you can incentivize some way, like Filecoin style. You could just have all the data there and like just have it available. That's all you need.
Yeah, but is it right that we need all the data to make sure that the chain is still liquid? Otherwise, what's the point of having part of the data?
For Plasma Cash, you only need the data for your coin. So
it's cash. Okay, got it.
I'm just thinking in that context. For MVP, I'm not sure. But for Plasma Cash, for example, you could have an operator that a secondary like layer of operators that could modify, that could like be providing data availability for certain coins. So it wouldn't be like the operator, these kind of entities, they would not have like write access to the Plasma chain, but they would be constantly polling the operator for the data, and they would be keeping it there with some cost that they're covering somehow, and they would be providing the data to other users. So even if the operator goes down, or maybe they're better network than the operator because they're to closer proximity, like network-wise.
Yeah, and those people are can also provide the challenge response kind of feature. So for the users.
Right. Exactly. Like imagine that you run your company, you run your company, like, so essentially you run a hub in your company, and that hub connects to the Plasma operator so that you do not require all the users inside your company to be running the nodes, to be holding the data. So you can just have, like, this is good, I think. Like, do you get where this is going?
I mean, just transferring the trust. Instead of trusting the operator, you now trust that.
Trust, yeah, but it's inside your own company. That's what I'm in that context. So, yeah.
Why do you need an SPV node at all? Why not just have someone just tell you what the?
Sure. Okay. That eventually that's what I'm getting at. Yes.
So I mean, the thing is, like, you don't really, since if you actually want to have an SPV node that can verify and like with unbonded, like no one has any bonds, SPV nodes don't make that much sense, I think, because in any case you would need to run an SPV client for Ethereum to like be able to verify those proofs against the root hashing tool in the contract.
I think just the bonded operator with providing guarantees saying, this is included, that's not included, and if I'm wrong, then here's a bond. You can even have an operator that says, I'm going to watch your coins, and if your coin gets stolen, then I lose my bond. So like, I feel like this constrained operator, just like Dan is always talking about, it's like the way to go. Super cool.
Okay, but do we have any formal proof for bonded operator? For like, how do we prove that the crypto economics hold? That's my main. How do you prove it? Like, okay, like doing a Nash equilibrium table is nice, but yeah.
Totally. So the Plasma chain always have like if Plasma chain holds the more value than the bond values. It has. Like,
how do you prove that is always the case? That's what I'm saying. That you do not know exactly. That's what I'm saying. So, but you need to prove it somehow.
You can measure the amount.
I don't think it's provable.
I think I agree. I'm not sure, but I think, yeah.
You can just measure the amount of ETH in the Plasma contract. That lets you.
Yeah.
And you require the operator to adjust their collateral.
No, yeah, I mean, like, so it's possible. I think it's just extremely capital inefficient. I wouldn't.
Wait, in the root contracts, we could just you just disable deposits as soon as the collateral, the bond, like the value of the chain exceeds the
okay, but that only applies if you use Ether. If you use an ERC20 or some CryptoKitty style contract, how do you evaluate that? So sure, for Ether that could work because you can easily evaluate, like rather compare how much is bonded from the operator compared to how much value the actual chain holds. But then you need to know how much the ERC20s cost or the ERC721. And then you need an oracle.
If the Plasma chain is oracle, then you can just use Merkle proofs for the prices.
Yeah. And then the Plasma contract costs more than 9 million gas to deploy.
actually, on that subject, I don't think for specifically for plasma cache, I think the coin validity proofs should end up being really short with SNARKs.
Sorry, could you repeat?
I think the coin validity proofs in plasma cache can be really short with SNARKs. Like
I think you run into a problem. You have to validate Merkle proofs, right, in the SNARK.
Yeah.
So then you're like, that's expensive, right?
Well, there are supposedly some Stark efficient hash functions people are working on, right? Like MC.
Yeah, you have to use one with
There's like Peterson commitments that
multiplying
will do it kind of efficiently.
Talk to you in 2 weeks.
Right.
Oh, see ya. You can do Peterson commitments, and that's what Zcash did to get rid of, like, you don't need all the properties of.
Could you give a link?
Are you sure that they decided to do the Peterson for the main tree? I think they postponed it.
I don't know.
I think they did it for something else, but not for a main tree. But yeah,
right now, I think they are. They have.
Yeah, but we are not about Plasma right now. Sorry.
But the idea is that if you need to do a Merkle proof for every single block, then you're kind of bound by the time that it takes to calculate a Merkle proof within a SNARK. And it gets really, really expensive really fast.
Yeah, it's super expensive for the person making the proof, but like the only worry is how do I validate this plasma chain when I'm on my phone? Like it's theoretically possible to.
Correct. Yeah.
I think I agree with Calvin. I think like it doesn't make sense even to use, I think, a non-stateful thing like Plasma if you're using SNARKs. I think the thing to do would be to keep a state commitment in like the current header and then do a SNARK proof of every state transition is valid. And you can prove that even to the main chain maybe, or at least make that data.
Yes.
And then we get to the problem of deposits.
I'm sorry?
We tried to discuss it the last call.
Right.
You can do one application. You can maybe even do thousands of applications of transactions from one state to another. But then you get to the problem of write deposits and withdrawals. And this is where it's getting very difficult. But
you end up having to include the Ethereum state root inside of your Merkle proof, right? Like that's the sort of annoying thing. You have to point that I can prove that there exists some deposit, in the state root in Ethereum as part of.
No. You don't need to prove this. You just, in a smart contract at every deposit, you just write something. And then you say, okay, I made all the deposits which were requested by something which made this particular hash or something like this. But the problem is number of constraints. It seems like 1 million per one state transition if we go with a deep tree, even with the modern hash functions. 1 million is okay. You can more or less prove it fast, but you need to prove this 1 million multiplied by, let's say, 1,000 each block. And it's a huge amount of time. And I don't know if it's parallelizable.
Yeah, it takes like a few hours to make the SNARK. If you're using dedicated hardware.
Well, just to check the parallelization. Maybe it's possible to calculate in a cluster and everything. There was a recent paper. The paper actually was verifiable delay functions. They have a reference for SNARK computational parallelization.
Yeah, I don't see why you wouldn't be able to parallelize the Merkle proofs if.
The polynomial division at the end, when you make a full proof for a SNARK, it's what I'm not sure about. I think the division is parallelizable if you go with 50. Yeah, I think it's we're a little off topic. We can just more or less discuss it in general.
Okay. Yeah, it sounds like you've done a lot of research on this topic, Alex.
I want to build plasmas this way, but it's so far. It's like a year at least to work. And I think I will need to write my own GPU prover.
Oh man.
Is anybody working on account-based Plasma?
This is what it's for.
Yeah, okay.
Yeah, we are working on it. So basically, we are actually implementing UTXO in like ERC20 contracts. So we have like logs where input 1, input 2, output 1, output 2, and you can check like when you exit in the queue, anyone can challenge like, okay, this nonce is, I mean, you are missing one nonce and this input and output is not valid kind of stuff. But the problem is that our proof is getting very big one, because we are using EVM only, because we want to make it easy, easy for like users to move to the plasma chains instead of making the new one. But yeah, there are some problems, but we are actually trying to solve this thing.
Cool.
Yeah.
All right. Looks like we're beginning to run out of time. Are there any other topics to discuss quickly?
Can I ask for a topic which is a little bit off from plasma, but I think it's the only place where I can more or less get an answer. Yeah, if you don't mind, when is it going to be a network? If someone knows, I just want a reduction of the price at few precompiles. It's like I have 4 or 5 ideas we can easily do, and I think would be good for a blockchain as itself and for Ethereum, like applications you can do on a blockchain with smart contracts and everything, a fun crypto. But now it's too expensive. And
what do you have in mind?
Well, starting from confidential transactions to democracy, a bond-based system for confidential voting where you can, so an operator always have to assemble the votes and everything and use his computational power, at least these parts. And well, the ring signatures people already try to use, also very good. SNARKs, which cost not 3 million, but something like 200,000 gas, is also very good. So we can play with more primitives.
Cool. Yeah, those are all fun ideas to explore for sure. Yeah, that sounds like good topics. I think those of you listening could definitely, maybe explore some of these topics too. And Johan, definitely thank you for joining us, and see you again soon, hopefully. Yeah. See you, everyone. Thank you.
Bye, guys. Take care.
See ya. That was so much fun.